to solve triangle ABC. Angle A is 42.3 degrees, side B is 12.9 meters, and side C is 15.4 meters. If it helps you, you are always welcome to draw a picture. I realize I have not been doing that on very many of them, but you certainly can if it makes a difference to you. That's 42.3 degrees, side B is opposite angle B, side C is opposite angle C. Can I use law of sines? No, the only time we can is if we have an angle side pair, and we don't. So cosines would be what we have to use. So first we need to find side A. That's one we're missing. So we can do the law of cosines. There's 3 of them, just depending on which side you want. That's basically the side you need equals the other 2 squared minus 2 times those sides times the cosine of your angle. And like I've mentioned, you're not memorizing any of these formulas. They're always given. So if we plug in 12.9 squared, 14.4 squared, 2 times 12.9 times 15.4, cosine of 42.3 degrees. And if you want to get rid of the square, we'd square root, so we might as well just type it in as the square root of that whole thing. Do that, we get side A to be 10.47 meters. If you say 10.5, that's fine, but we are actually going to have to use this later in the problem to find some things, so it might be helpful so you have less rounding error if you keep a few more decimals right now. So even if you did like 10.474, that would be fine. I've been doing significant digits, but that first number, we're going to use it, and depending on how you round it, it will throw off your other numbers slightly. So do make sure you're showing me that work so I know where it came from. So now, solving the triangle means find all the missing pieces. I need to find angles B and C. If we want to do that, we're going to have to use law of sines. And we now have both side A and angle A. We could find either B or C, but I think it would actually be easiest to find angle C because we don't want to have to worry about the case where we have 2 triangles. And this would be a little bit easier because I know side C is the biggest side in my triangle, so angle C will have to be the biggest angle in my triangle. So it might make it easier, may not. You know, worst case scenario, you work it out and one of your triangles doesn't exist. But if I go with that, we have 10.47 with sine of 42.3 degrees equals 15.4 over the sine of angle C. Cross multiply. Divide. So we get the sine of angle C equals 98991. And then we know to find the angle, we do sine inverse. So C turns out to be KB1 depending on how we went around. If I round to the nearest tenth, 81.9 degrees. Okay. I still don't really know if there's a second triangle. We know that if we had a second triangle in quadrant 2, it would have to be 180 minus that angle. Which would be 98.1 degrees. In either of these, we can find angle B by subtracting from 180 the two angles we know. So 180 minus 81.9 minus the 42.3. That tells me B is 55.8 degrees. If I did this one, 180 minus 98.1 minus 42.3, we get 39.6 degrees. Still any blatant issues with that? I mean, we didn't get a negative, but we do know angle, or side A was the smallest of the three sides. So angle A has to be the smallest angle. So is that second triangle possible? No, because we got angle B to be smaller than angle A. So this one doesn't work. There is, in fact, only one triangle here. So that's kind of the downside when you do the law of sines. You do have to take into consideration both triangles. But luckily, once we have one angle, we just have to subtract from 180 to get the other. So it's not necessarily a lot of work. You just have to think a little bit there. Questions? These have a lot of potential for rounding error. Just a difference in how many decimal places you go to on one step will throw off things. So just make sure you're showing enough work so I know your answer is off by a decimal because you rounded earlier in a problem to a different spot. That's not a big deal as long as I know how you got there. All right. Do we need another problem like that? That one was kind of set up like the two we did yesterday. We knew two of the sides and one of the angles. Do we need another one? Okay. Then I'd like to look at the final situation. So we've basically seen where we have two sides and an angle. What do we do if we have three sides? We could solve for whichever angle we wanted first. So if we, I don't know, let's pick, if I wanted to solve for A. A would have to be the smallest angle in my triangle, right? Because that's the smallest side. All right. Can I do law of sines? No. So we have to go with cosine. So if I'm using the A formula, A squared equals B squared plus C squared minus 2BC cosine of A. So if I plug this in, formula looks pretty ugly just because we have so many variables, but keep in mind, all we're trying to do is get this cosine A by itself. So we have to subtract over the 15.9 squared and 21.2 squared and divide by the -2 times 15.9 times 21.2. sine, cosine is positive in quadrant 1 and 4. So when we're doing that, if we do our reference angle, so cosine inverse 0.90864, we get 24.68 degrees. But if you put that in quadrant 4, then 360 minus that, is that possible in a triangle? No. So when we're doing law of cosines, we're only going to get one possible angle that works. So now I have angle A. Alright, we need two angles, so we need angles B and C as well. At this point you have two options. You could repeat the same thing to get B and C, or really to get one more and then subtract 180. Or we could do law of sines. Either way, we're going to get there. So do you want to do law of cosines or law of sines? Sines? Okay, so we have A, so we'll have to do A over sine A equals, let's do B. So side A was 9.47. For the sine of 24.68 degrees equals side B, 15.9, over the sine of angle B. Cross multiply, divide by 9.47. Get sine of B to equal 0.7106. Then you have to do sine inverse. And if we do that, we get 44.51 degrees. You would need, when we have law of sines, we have to think about the possibility of a second triangle. If we did that though, 180 minus 44.51 is 135.49. If we think back to our problem, side C is the biggest, so that means angle C has to be the biggest angle, has to be the obtuse angle. So can angle B be 135? No, we do only have one triangle here. And so then to get C, you just subtract from 180. So we get 110.81 degrees. There is a lot of potential for rounding issues in this as well. So it all depends on how many decimal places you kept earlier, if you rounded, when you rounded significant digits. So as you're working through these, it's possible your answer might be slightly different due to that rounding error, but it should be pretty close. Like I think this example, the answer in the book said C was 109.9 because they found that one first using the law of cosines, and that was the one we found last, so it had more rounding error. So just know that that can happen, but they should be pretty close. All right. Does that make sense? Do we need another problem like that? You want to try some? So I am not going to give very many of these. I really just want to see that you can